How do we find the exact value of cosine of 20 degrees times cosine of 40 degrees times cosine of 80 degrees? It's hard to determine the values of each individual term, but we can find the value of the product of all three terms if we make good use of a trigonometric identity. We will let x equal cosine 20 degrees, cosine 40 degrees, cosine 80 degrees. Our objective is to find the value of x. Recall the double angle identity for sine, which is sine of 2 theta equals 2 sine theta cosine theta. If we divide both sides of this identity by 2 and switch the order of the equation, we get sine theta cosine theta equals 1/2 sine of 2 theta, which is the form of the identity we will be using for this problem. If we multiply both sides of the equation in terms of x by sine of 20 degrees, we get sine of 20 degrees times x equals sine of 20 degrees, cosine of 20 degrees, cosine of 40 degrees, cosine of 80 degrees. Let's focus on the product sine of 20 degrees times cosine of 20 degrees on the right-hand side for a moment. This expression is in the form sine theta cosine theta. If we use the double angle identity, we can rewrite this part as 1/2 sine of 40 degrees, and the rest of the expression stays the same. This is where the magic really happens. The sine of 40 degrees and cosine of 40 degrees terms in the new expression form another product in the form sine theta cosine theta, which means we can use the double angle identity to rewrite sine of 40 degrees cosine of 40 degrees as 1/2 sine of 80 degrees. The new expression on the right-hand side becomes 1/4 times sine of 80 degrees cosine of 80 degrees once we simplify the product. Since sine of 80 degrees cosine of 80 degrees forms another expression in the form sine theta cosine theta, we can rewrite this as 1/2 sine of 160 degrees, and the entire right-hand side expression simplifies to 1/8 times sine of 160 degrees. By multiplying sine of 20 degrees on both sides of the equation, we get a cascading effect with repeated application of the double angle identity for sine, which condenses the right-hand side expression into a single trigonometric term. Let's look at the sine of 160 degrees term on the right-hand side for a moment. There is a basic identity which states that sine of 180 degrees minus theta is equivalent to sine of theta. We can use this identity to rewrite sine of 160 degrees as sine of 20 degrees. The great thing about this is that we now have sine of 20 degrees on both sides of the equation. We can divide both sides of the equation by sine of 20 degrees, since sine of 20 degrees is non-zero, which leaves us with x equals 1/8. We originally let x equal cosine of 20 degrees, cosine of 40 degrees, cosine of 80 degrees, and worked out that x equals 1/8. Therefore, we can conclude that cosine 20 degrees, cosine 40 degrees, cosine 80 degrees equals 1/8, which is the exact value of the original expression we were trying to find.